Hi, this is Saranya, Assistant Professor from Dr. SNS Rajalakshmi College of Arts and Science. Today we are going to see the lecture series Theory of Computation. In the Theory of Computation, we will see the basics, introductions about Theory of Computation. What is meant by theory of computation? First of all, the word theory is none other than explaining in detail. And then computation. The word computation is a movement, as well as we used to say this some alteration which deals with transition of data or processing of data from one place to another. So for that method is known as computation. So the theory of computation, which includes the basic mathematical properties of computer hardware, software, as well as and their applications. First of all, theory of computation is defined as a branch of computer science, as well as it's going to deals with mathematical model in order to solve some problems, real-time problems in an effective manner by using some technical methods. We used to call it as computational methods, or else in computer term we used to say some new algorithms we are going to propose in order to solve some real-time problems. So that's what we used to call as a theory of computation. And why the theory of computation is so important? Let's see the three effective manner we are using the theory of computation process. For in order to write some efficient algorithm to solve some computing problems, real-time problems, and all solved by using some new algorithms in latest technology, by implementing some machine learning applications, as well as in order to develop some artificial intelligence applications and all, we are proposing some algorithms. So in that terms we are using some mathematical model. So there and all we are implementing theory of computation methods. And also theory of computation is very much important by developing some programming language in order to do some research, as well as in order to develop some applications. We are implementing theory of computation. And then efficient compiler design, and as well as in order to construct some model, we are embedding the theory of computation methods. Next, let us see the branches of TOC. TOC is none other than theory of computation. Three important branches are there in order to propose the theory of computation. First theory is none other than automata theory, and then computability theory. Finally, we used to call the complexity theory. So in this way, the theory of computation is dividing the branches. First, let us see the automata theory. So the word automata is none other than machine. So by using some set of machines, we are going to solve some technical real-time problems. So first, let us see the automata theory. So automata theory is also known as theory of computation. So the automata theory, in order to solve some simple problems, we used to propose this automata theory. The word automata, by using some set of mathematical models, we are at the same time, in order to solve some technical problems, as well as some real-time problems, for simple problems and all, we used to propose this automata theory. In theory of computation, automata theory plays an important role in order to solve some problem by using some computation methods. Let us see the examples, such as for automata theory as a finite automata, and then context-free grammar. For writing some algorithms and all, we are implementing the machine, the finite automata. And then context-free language for implementing some in order to develop some model by using some programming languages, we used to implement the complex context-free grammar. And also Turing machine, that is also one example for automata theory. Now let us see what is meant by computability theory. The computability theory is one of the important branch in theory of computation. In that, the computability theory deals with what can as well as cannot computed by model. So the theoretical models are proposed in order to understand the solvable as well as unsolvable problems, that by using some mathematical methods, or else we used to say computability methods. That's what we used to, for that reason we are implementing the computability theory. So the theoretical model sometimes proposed in order to solve some real-time problems. And then next important thing is complexity theory. So the complexity theory, in order to solve some complex problems, so for that reason we are implementing this complexity theory. We are first of all we are grouping the problems, and then the coordinates and all finding out by using some sort of mathematical models, and then finally by implementing the complexity theory methods in order to solve some real-time problems. So these are the important basics of theory of computation. So in this we clearly understand the basics of theory of computation, why theory of computation is very important, and then we see the branches of theory of computation. We have three important branches. One is automata, and another one is computability, and then complexity. So with these theory we are implementing we are creating some new algorithms in order to solve some real-time problems, finding some successful solution for solving the problems in effective manner. So this is the main reason of implementing the theory of computation. Let us see, before concluding, let us see the applications of theory of computations real time அப்படின்னு சொன்னோம்னா. Let us say some example as lift, elevator, as well as we used to call the marketing and all. We are implementing theory of computations. And then cloud computing also we are implementing the theory of computation concepts. Okay, thank you for your patient listening. Thank you.